In 2006, the United States government intentionally spent millions of dollars to systematically destroy 165 of its own $38 million fighter jets. The Pentagon ordered the fleet dismantled specifically because the engineering was too effective to risk letting the components survive on a global market. It is a rare moment in military history, a superpower mandating the total physical execution of its crowning engineering achievement. The F-14 was born from a 1968 Navy requirement that defied the physics of the era. The military needed a platform capable of slow carrier landings, yet powerful enough to execute Mach 2.34 supersonic intercepts. This illustrates the barrier of trim drag. Passing the sound barrier, the aerodynamic pressure center shifts violently backward, forcing the nose down uncontrollably. To solve this, engineers utilized variable sweep wings that automatically pivoted mid-flight, stabilizing the pressure center and allowing high-speed stability. These shifting wings relied on dense, experimental titanium joints connected by electron-beam welds, a manufacturing process that pushed the limits of 1960s material science. Solving the aerodynamics created a secondary crisis. The aircraft now required a way to calculate and manage these massive physical forces in real time without human input. Managing the sweep of the wings and the resulting structural stresses required a level of computational power that simply did not exist in aviation at the time. Engineers Ray Holt and Steve Geller produced a solution so advanced it remained classified for 30 years, the MP944 microprocessor. This was the world's first multi-chip microprocessor. Its 20-bit architecture fit a 40-square-inch card on just 10 watts of power. This hidden computer processed 5,490 calculations per second, adjusting flight surfaces to prevent the airframe tearing apart at Mach 2. For 3 decades, the public history of the digital revolution was incomplete, obscured by the fact that the F-14's physical flight was entirely dependent on this secret, real-time binary processing. This engineering carried a heavy burden on the ground. The complexity of the wing sweep mechanism created a maintenance tax, requiring up to 60 hours of labor for every single hour of flight. Despite these costs, the United States sold 80 of these advanced interceptors to the Shah of Iran during the 1970s. The 1979 Iranian Revolution changed the calculus of that sale, placing America's most lethal aviation technology in the hands of a new hostile government. In the regional conflicts that followed, Iranian pilots used the Tomcat's advanced radar and computational power to operate as miniature command centers, claiming an astonishing 43-to-1 kill ratio. The aircraft's mechanical superiority in the Middle East created a direct and long-term logistical risk for the United States. By the mid-2000s, the bespoke nature of the F-14's titanium parts and microchips had created a desperate, high-stakes global supply chain. To keep their fleet airborne, Iranian intelligence agents began infiltrating U.S. surplus auctions to scavenge for restricted replacement parts. GAO undercover investigators discovered a massive security failure, finding that restricted F-14 components were being sold openly on public websites like Craigslist and eBay. The Pentagon's response was a legislative shutdown known as the Stop Arming Iran Act, intended to collapse the secondary market for Tomcat parts entirely. The scarcity of these custom parts left the United States with only one way to secure the technology: the total physical destruction of every remaining airframe. The government hired the contractor TR Rents to perform the execution, with orders to reduce the legendary jets into 2-foot cubes of scrap metal. The 100,000-pound industrial shears easily tore through the aluminum wings and standard fuselage plating, violently reducing the outer shell into twisted scrap. But the titanium landing gear, built to withstand carrier impacts, jammed the 120,000-pound shredder. The engineering was so resilient, the heavy machinery could not chew through it. To complete the destruction, crews had to use demolition torches to manually cut the flawless titanium joints apart, piece by piece. The indestructible materials and precise engineering that define the Tomcat's legend were the exact reasons it had to be violently erased from existence.